There's two ways to solve a system of equations algebraically. You can solve the system by substitution or by elimination. You might have a preferred method. Normally you want to use the substitution method if you have one variable already by itself, like if it had said x equals something or y equals something, or you could easily get one piece by itself, how this x doesn't have anything attached to it. You want to use the elimination method when you can easily cancel one of your variables. Either they have the same number in front, or you can multiply one to get the other. Those are times you do elimination. I'll do this problem both ways. So first, to do the substitution method, you would have to get x by itself. So I'm going to add 2y to both sides. And I get x equals -4 plus 2y. So once I know what x is equal to, right, x is equal to this, I'm going to plug it in where my x used to be. X equals this, so I can plug it in where there is an x in my second equation. So I have 3 times -4 plus 2y plus 4y equals 18. I'm going to go ahead and now just solve this problem. I distribute to get -12 plus 6y plus 4y equals 18. Keep solving. I'm going to add 12 to both sides. I get 10y equals 30. Divide both sides by 10, and I get y is equal to 3. The system of equations is going to be, the solution will be a point, just like when we graphed them, the solutions was a point. So the way that we get our second part of our point, once I know y, I just plug it back into the original equation. Either one, it doesn't matter, but I'm going to plug in where it used to be a y, I'm going to plug in a 3. So x minus 6 equals -4, and then I add 6 to both sides to get x equals 2. To write my answer, I would put it as an ordered pair, 2, 3. So that's the substitution method. You have to get one variable by itself, and then you plug it into the other equation. The other method that we have is called the elimination method. So in order to do the elimination method, you're trying to eliminate one of the variables. I'm going to go all the way back to the beginning, and I'm trying to see if either they have the same coefficient in front, or I could easily multiply one of the equations to get the pieces to be the same in the front. So here's my original problem. So when I look at my pieces, right now my x's won't cancel, and right now my y's won't cancel. Since I have 1 minus and 1 plus, that's a good thing because a positive and a cancel each other. Positive and a negative cancel each other out. This one has a -2 and this one has a 4. What that means is I can multiply this -2 in order to get the 4 to cancel. So I'm going to multiply this whole top equation by 2. And what's going to happen is I'm now going to have a -4y. Everything got multiplied by 2. 2 times x, -2y times 2, and -4 times 2. All of them got multiplied by 2 and got 2x minus 4y minus 8. So this new equation, okay, if I just use these two equations now, one has a positive 4y and one has a -4y. So they cancel each other out. I get 5x equals 10. And then I can just easily solve that by getting x equals 2. I already know what the answer is because I did it earlier. It was 2, 3. But once I plug this into one of my original equations, it doesn't matter which one. I'm going to plug where the x was, I'm going to plug in a 2. So I subtract 2 on both sides. I get -2y is -6. So that means that y is equal to 3. And I put my answers in ordered pair, 2, 3. So that was an example of both ways, substitution and elimination. Both ways I'll get the same answer.